Hey sixth graders, this is lesson 9-1 and we're going to be looking at negative numbers today and talking about how you can have positive numbers and negative numbers in real life. And also we're going to be identifying what opposite numbers look like on a number line. So I haven't done this lesson yet. Obviously it's the beginning of the video, but I anticipate it's going to go really quick. So you guys have earned a short one. Okay, so the first problem says, the cliff diver below is poised to dive from the top of a cliff that is 60 feet above sea level. So she's up here, and this distance is 60 feet, okay? So from where she is into the ocean is 60 feet. It's 60 feet above sea level is what they call it. Now, if the distance she travels underwater, so this part, right, once she dives under, is 1/4 the distance that she travels above water, then how would you describe her location at the deepest part of the dive? So like how far is she right here? Well, I do know that it's 1/4 of the distance that she travels above. And the distance she travels above, if she goes woo and then dives down, it's 60. So 1/4 of 60, we know from our work this year that of in math means multiply. So it's 1/4 times 60. Okay. And I also know that when I multiply, I need two numbers that are fractions, like a numerator and denominator. I can't have a fraction and a whole number very easily. So I multiply straight across. My numerator, 1 times 60 is 60. My denominator, 4 times 1 is 4. And then I remember that fractions are just a dividing bar. So 60 divided by 4, and I know what that is, it's 15, but if you did not, it's okay to do that off to the side. 4 goes into 6 one time, 1 times 4 is 4, subtract, we get 2, bring down our 0, 4 times 5 is 20, and we get 15. So I would say, to describe her location at the deepest part of the dive, this was 1/4 the distance of above water, which we found out is 15 feet. Okay, so we could say that she is 15 feet below sea level, right? So if she is described as 60 feet above sea level when she's up here, we could say she's 15 feet below sea level when she's down here. All right, number 2, protons and electrons are parts of an atom. This is a science question. A proton has a positive, a plus sign, electrical charge, and an electron has a negative, a minus sign, electrical charge. So here's all of these. In this illustration, is there a positive electrical charge for every negative electrical charge? In other words, are they all matched up, or is there an even number of both of them? So I'm just going to try to pair them to see if they are equal or not. So I'm pairing up positives and negatives. Did I get all of them? Yep. So is there a positive electrical charge for every negative electrical charge? My answer would be yes. They are each paired up. And so in other words, this atom, this science word, would not have a positive charge or a negative charge because all the positive and negatives would pair up and cancel each other out. So it would have a neutral charge. All right, so number 3, a checking account has a balance of $80. Okay, so that means that there's $80 left in their bank account. Then a check is written for $100. So the check number is 409. That doesn't really mean anything to you guys. But they spent $100. In their bank, they only had 80, but they wrote a check for something that cost 100. Using words, describe the new balance. So what could we say if they had 80 in their account and the bank says, you tried to write a check for $100, but you only have 80. What could they say for the new balance? Well, we could say the balance is below 0, right? Because the bank says you spent all that 80 bucks and then you spent $20 extra. So if we want to be more specific, we could even say the balance is $20 below 0, right? They spent too much money. All right, so these are 3 pretty simple real-life examples of when it would be helpful to understand negative numbers. We didn't really talk about the words negative necessarily, except when it said a negative charge, but that wasn't a math thing. But this is getting you familiar with the idea that negatives do exist in real life. So, to finish up this lesson, I told you it was a quick one. We're going to talk about something called an opposite. It says 2 numbers are opposites if they are the same distance from 0 on a number line, but they're in opposite directions. So if 2 temperatures are opposites, they are the same distance from 0 on a thermometer. If one temperature is above 0, then the other will be below 0. The opposite of 0 is 0. Okay? So each arrow on the Fahrenheit thermometer, Fahrenheit is just a way of doing degrees Fahrenheit. You guys have seen that before. Points to the temperature. Write the temperature. So all we have to do is write the temperature. So number 4, what temperature is that pointing to? Notice that if it's between 10 and 20, these numbers are increasing as they go up, okay? And if there's only 5 marks there, that means they're skipping by 2. So I have 10, 12, 14, 16, 18, 20, right? So they are skipping by 2. Okay, so 10, 12, 14, 16. So we would record this as 16 degrees Fahrenheit, okay? For 5, we would say, or we could say this is above 0, okay? Now for number 5, this is 10. We're kind of going backwards here because we're counting down. This would be 8 degrees Fahrenheit because we dropped by 2. Above 0. Okay, or we could have started at 0 and said 2, 4, 6, 8. Okay, now number 6 is pointing to the first mark above 0, which is 2. So 2 degrees Fahrenheit above 0. Now what's number 7 pointing to? 7 is pointing to exactly 0. So we could just call it 0 degrees Fahrenheit. We're not going to call it above 0 because it's not above 0. It is 0. Now what about number 8? 8 is actually below 0. So on this thermometer, this is when we get introduced to negative numbers a little bit. Here's 0. I'm going to make a big line here. Anything above this, we call it above 0. And these numbers count up, right? Okay. But anything below the line, these numbers are, in fact, below 0, but what's weird is they also count up. Now this is confusing for a lot of kids because they go, wait, how are they counting up if they're going down? That is confusing. We are used to counting up as we go up and going down as we go down. But notice anything that is below 0, if you are going down, the numbers still count up. We go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay, so both directions count up. This is where we get the idea of opposites, okay? So for number 8 here, what is the temperature? We have 0, 2, 4. So we call this 4 degrees Fahrenheit, but instead of above 0, we call this below 0. And you might also know this as negative 4 degrees Fahrenheit. If it's below 0, it's negative, okay? Then number 9 is right here. So we have 2, 4, 6, 8, 10. Right here is at 12. So this is 12 degrees Fahrenheit below 0, or you could say it is negative 12 degrees, okay? And then number 10, if we keep counting, this was 12, so 14, 16, 18 right here. This is 18 degrees Fahrenheit. You might hear people say in real life, it's 18 below outside, or you might hear them say, it's negative 18 degrees outside, okay? All right, now this second thermometer works exactly the same way. except some places in the world measure instead of Fahrenheit, they measure in Celsius, and that's something you'll learn about later in science, but it's just a different way to measure a temperature, okay? So the thermometer works the same way. It's the same activity. We're just counting it in degrees Celsius instead of degrees Fahrenheit, all right? So number 11, oh, here's my big 0. I'm gonna make this stand out a little bit because anything above the 0, we call above 0, and anything below the 0, we call below 0. So number 11 is pointing right here. So I'm at 10, 12, 14, 16, 18. So it's at 18 degrees. Oh, I almost did an F. I did do an F. 18 degrees Celsius, because this is a Celsius scale. Oh, by the way, it does tell you right here, degrees Fahrenheit or degrees Celsius. It does tell you at the bottom, so you know what your unit of measurement is. And this is above 0. And then number 12, right here, it's pointing directly to the 10, and it is above that 0 line, so we call it 10 degrees Celsius. Some people will call it 10 degrees Celsius above 0. 13, we got 2, 4, 6, so it's right here at 6 degrees Celsius. Some people would call it 6 above or 6 degrees above 0. Number 14, ooh, now we are below that 0 line. So instead of counting backwards on a thermometer, we are still counting up. So notice that the lower we go, the numbers are still counting up higher and higher to 10 and 20, but there's this negative number, okay, or this negative symbol. So what we can write is number 14 is 2, so we can say it's 2 degrees Celsius below 0, or some people would call that negative 2 degrees Celsius, okay? All right, then we've got number 15, which is negative 10. It's pointing right to that. So we can call it 10 degrees Celsius below 0. And then if we want to, we could call it negative 10 degrees Celsius because it's 10 below. Then number 16 is right here. It's pointing, it's between the 10 and the 20. So we got 10, 12, 14. It's right here at 14 degrees Celsius. So we call it 14 below 0, or some people would just call it negative 14 degrees. And then our last one, 17, is pointing right at the 20. So we can call it 20 degrees Celsius below 0. 20 below, or some people instead of 20 below, they'll just call it negative 20, okay? So it's kind of an introduction into real life negative numbers, and when you're talking about temperatures, people will either call it below 0 or they'll just call it a negative temperature. They mean the same thing, and that will continue on in our learning throughout our next lessons, that when you are talking about numbers below 0 or before 0, those are going to be negative numbers, and they will, it seems backwards, but they're, even though you're going the opposite direction, you're still counting up. So it is a little bit confusing, but we'll get to practice on our next few lessons. All right, hope you guys enjoyed that short one.